In this video, we're going to be talking about solving systems by substitution. In another video, we talked about solving systems by graphing. So we had a couple of linear graphs that formed an intersection, and that intersection was the solution to both of those equations. So when I say solving systems, again, I'm talking about where is that intersection, what's the coordinate, the x and the y value, and that coordinate will also when you plug in whatever value for the x and the y value, what that coordinate is, it will work for both equations. So the step-by-step process of solving by substitution, step one is to solve for one equation. So you want to get y equals something or x equals something. So you want to isolate one of the variables on one side of the equation. Step two is substitute, that's why it's called substitution, the resulting expression in the other equation. So like let's say I had y equals this, I would plug that stuff in for y in the other one. Step three, solve for the first variable. And step four, use the first variable in one equation to find the other. So what I say is plug it in one of the equations and you're going to find the other one. So you're going to hear me say that a lot. So it sounds kind of confusing when there isn't a problem in front of you. So let's take a look at one of the systems of equations, and you probably see a bracket on a lot of them with the steps right here. So step one, solve for one equation. So you want to get x equals something or y equals something on just one of them. You don't need them for both of them, but just one of them. And you notice that for this one, both equations are solved for y. So step one, we're good. You can check that off. Step two, substitute resulting expression for the other. So for these problems, that step is actually pretty easy. So you can do this a couple different ways. You could take this stuff, since y equals that, I like to make a box, and swap that out for y in the other one because y equals that. Or you could go the other way around, use the second equation and say, well, if y equals that, why don't I substitute that in for y in the other one? Okay, so you can think about it either way. I'm going to do it this way since I already have it written. So I'm going to swap out the y with negative 6x minus 18. So it's kind of like you're putting something in, plugging it in for y. So negative 6x minus 18 equals 7x plus 21. Okay, so we got rid of that y, put in that negative 6x minus 18. So that was the substitution step, so we're done with that. And solve for the first variable. So basically, solve for the variable that's in my equation here. So you notice how I have x's on both sides. So what we're going to do is get all the x's on one side, get all the numbers on one side. So it really doesn't matter how you do it. Like let's say I want the x's on the left side, so that means I have to get rid of this x term right here by subtracting 7x on both sides. So I'm going to get a negative 13x minus 18 equals, so these will cancel, 21. And then I'm going to add 18 on both sides, get that x term by itself. So I'm going to get a negative 13x equals 29. Or sorry, plus 18, that'll give me a 39. Okay. And then I'm going to divide both sides by negative 13, because that's what's in front of the x. So those cancel out. I have x equals, and 39 divided by negative 13 will give me a negative 3. So that was step 3, solve for the first variable, x equals a negative 3, but I need to find the y value. So use the first variable in one equation to find the other. So you can choose either one of the equations of your original and plug in negative 3 in for either the first one or the second one. It makes sense to actually use just the easiest one because it'll make your life a lot easier and go a lot faster. So let's choose the first one. So we have y equals 7 times negative 3, swap the x with the negative 3, plus 21. And now let's solve for y. So 7 times negative 3 will give me a negative 21. And negative 21 plus 21 will give me a y value of 0. So that's okay. 0 is a number. So I have x value of negative 3, a y value of 0. So negative 3 comma 0 is my answer. So if you're ever unsure, you can actually go back and see if it works for both of them. And this one, it does. You can do it in your head or punch it on the calculator or something to make sure it works, but this one does work for both of them. Okay, going on to another one. Don't forget your steps. Let me actually get the steps on here once again. So here's another problem. I have the steps up here. Step 1, solve for one of the equations. Since they're both y equals something, they're actually both solved, so we're good there. Step 2, substitute resulting expression in other. So once again, you could take, since y equals this, you could plug that in for y in the other one, or you could go the other way around and put in the x plus 8 and substitute that in for y in that one. So however you do it, you're going to get x plus 8 equals 7x plus 8. You could have the left and the right side switched around depending on how you do it, but your problem will still work out. So we got that. Solve for the first variable. So get the x's on one side, get the numbers on one side. So I like to have the x's on the left side, so let's get rid of the x term on the right side by subtracting 7x on both sides. Gives me a negative 6x plus 8 equals 8. Then we have to subtract 8 from both sides. So I'm just going to have a negative 6x. That will cancel out, and actually these will cancel out, so all I have left on the right side is 0. And then when you divide by negative 6, I get x equals 0. So well, that was step 3. Step 4, use that variable in one of the equations to find the other. So again, use the easier one. The first one looks pretty easy, so let's use that one. So y equals 0 plus 8. So 0 plus 8 will just give me 8. So y equals 8 for that one. All right, a few more of this type. I have y equals negative 6x minus 7 and y equals 6x plus 17. So let's take this stuff, plug it in for y in the other one. So I'm going to have a negative 6x minus 7 equals 6x plus 17. Get the x's on one side. So let's subtract 6x on both sides. I get negative 12x minus 7 equals 17. Let's add 7 on both sides. I get negative 12x equals 24. Divide by negative 12. And I will get x equals a negative 2. So that is my x value. I need to plug it in for one of the equations. Again, it doesn't matter which one you choose. Looks like the bottom one might be easier. So we got y equals 6 times negative 2 plus 17, or y equals negative 12 plus 17, multiplying those guys together. And 17 minus 12, or negative 12 plus 17, will give me a y value of 5. So, and make sure you actually write as a coordinate negative 2, 5. I don't think I did that on the last one. Yep. So we have 0, 8. Make sure to write it as a coordinate. It's a little neater that way. So we have y equals 5x minus 4 and y equals negative 2x minus 4. Let's take the bottom one and put it in for y in the other one. So you might notice how you're taking just the right sides of the equation and setting them equal to each other. And that's because they're both solved for y, or they're both solved for one variable. So getting the x's on one side. Okay, so we got negative 7x minus 4 equals negative 4. Let's add 4 on both sides. So I get negative 7x equals 0. And dividing by negative 7, I get x equals 0 divided by negative 7 will just give me a 0. So x equals 0, plug it into one of the equations. Let's use the top one. I got y equals 5 times 0 plus, minus 4. 5 times 0 will give me 0, so y equals 0 minus 4, or y equals negative 4. So a point at 0, negative 4 is my solution for that one. So this next example, we got y equals 6 and y equals 2x plus 2. So once again, take what's on the right side, or look at the equation that's solved for one variable. In this case, both of them. So we can put that 6 in for y. So 6 is going to equal 2x plus 2. And then solving for x, let's actually just subtract 2 from both sides. I get 4 equals 2x. And solving for x, dividing by 2. So x is going to equal 4 divided by 2, which gives me 2. So x equals 2 there. So to find the y value, now what you could do is actually plug it into this equation and get your y value, but one of the original equations already tells me that y equals 6. So that already gives me my y value. What you could do also is just plug 2 in for x, so what do we get? Y equals 2 times 2 plus 2 if we plugged it into the other equation, which would give me y equals 4 plus 2, which would be y equals 6. Either way, you're going to get a y value of 6. So 2 comma 6 is going to be my answer. So here we're going to get into some problems when only one equation is solved for y, as we have here. So we have y equals 2x minus 4 and negative 4x minus 3y equals a negative 8. So it really doesn't change a lot when only one equation is solved. It just kind of looks a little different. So what you're going to do with these problems, you notice that only one equation has one variable by itself on one side, as we had just the y here. What we're going to do is take the other side of that equation, that 2x minus 4, and plug it in for y in the other equation. So right away, let's just rewrite that other equation, negative 4x minus 3, but instead of a y, I'm going to put parentheses, and that equals a negative 8. And in those parentheses is going to go that right side of the equation. So 2x minus 4. And we're going to solve for x here. So the first thing that we're going to do is distribute. So distribute that negative 3 through. So we have negative 4x minus 6x plus 12. And that equals negative 8. Combine like terms, so negative 4x minus 6x, that'll give me a negative 10x, plus 12 equals negative 8. Let's subtract 12 on both sides. So that cancels out. I have negative 10x equals negative 20. And solving for x, divide by negative 10 on both sides. So I have x equals, that's going to be a positive 2. So x equals 2. And we're going to take that and we're going to plug it into one of the equations to find out my y value. And again, it doesn't really matter which one you plug into. I'd always choose the easier one. So let's use the top. So plugging in 2 in for x, we would have y equals 2 times 2 minus 4. 2 times 2 gives me 4. So y equals 4 minus 4, which is 0. So my answer is, make sure to put in a coordinate, 2 comma 0. So we have another one. Look at the equation that is solved for y, so that's this one right here. That means we need to plug in that right side in for y. So we have 2x minus 3. Put those parentheses in for the y, equals 9. And in those parentheses goes the 3x plus 11. Distribute that number in front through. So we have 2x minus 9x minus 33. And that equals 9. 2x minus 9x, that gives me a negative 7x. And then we're going to add 33 on both sides. So these will cancel out. I'm going to get negative 7x is going to equal 42. And then divide by negative 7. So x is going to equal a negative 6. So x equals negative 6. And plug it into one of the equations to find the y value. Let's use that easier bottom one right here. So y is going to equal 3 times negative 6 plus 11. 3 times a negative 6 gives me a negative 18 plus 11. And negative 18 plus an 11. That's going to give me, let's see, get my head here. Negative 7. Not sure why it took me so long to figure out. Okay, so there is my answer. Negative 6, negative 7. So going on the next one here, you have the y equals negative 2x minus 3. We'll plug that in for y in the other one. So we have a negative 3x minus 7 times a negative 2x minus 3. Okay, and that equals 10. Distributing through the negative 7, that'll give me a negative 3x plus 14x plus 21. That equals 10. So I'm going to have, when I collect like terms, an 11x plus 21 equals 10. Subtracting 21 from both sides, that's going to give me an 11x equals negative 11. And when I divide by 11, I'm going to get x equals a negative 1. So we have that, the x value. Let's plug it into the first equation to get the y value. So using that whole equation there, use the easier one. So I'm going to have y equals negative 2 times negative 1 minus 3. Negative 2 times negative 1 will give me a positive 2. And then we got 2 minus 3. So the y value of negative 1. So the coordinate negative 1 will be my answer for that one. So the last set of problems that we're going to be talking about are systems when the equations are not solved. So that was the step 1 way back at the beginning of the video. We got to get one of them solved for one variable. So for these problems, what you're going to do is identify a single variable without a coefficient. So I'm just looking for a standalone x or a standalone y. So if you look at this set, notice how I have an x, I have a y, I have a negative 2x, and a 7y. So I'm actually not going to solve for x using the 7, this one, or this one. So we can just kind of cross those out. I'm not going to work with those. I'm going to only work with the ones that are just a single variable. Okay, so, and in this we actually have two choices. So a single variable without any coefficient in front. So I can use that x or that y. And basically what you're going to do is just solve for one of them. So in this case, you could choose either x or y. Since we haven't used x in a while, let's just solve for x on this one. So to solve for x, you got to get x by itself. So I need to get rid of the y. So we're going to subtract y on both sides. So that's going to give me an x on the left side. And that's going to equal a negative y minus 2. You can't combine those two together. One's a y term, one's another. Just keep them separate. And now, we're not even going to look at this equation anymore. We're going to look at this new equation right here with this one. So now that you have it solved for x, you're going to take this right here and plug it in for x in the other equation. So that was the step 2. So I have negative 2, and then put parentheses in for x, because I'm going to plug stuff in there, plus 7y equals 4. And what goes in there will be the negative y minus 2. So let's distribute the negative 2. So this is going to give me a positive 2y plus 2, or plus 4, plus 7y equals 4. Collect like terms, so we have 9y plus 4 equals 4. And subtracting 4 from both sides, I'm going to get 9y equals 0. And when I divide by 9, I'm just going to get y equals 0. So we have y solved. Now you can actually either use this equation, or even though I scribbled it out, you could use the original one here. Find one to plug it in. Again, use the easier one. Kind of looks like this one right here might be an easy one to use. So x equals a negative 0 minus 2. Okay, a negative 0 is just like a 0. And 0 minus 2 will give me an x value of negative 2. So the coordinate negative 2 comma 0 is my answer for that one. And you can always go back and check your answers, like plug in negative 2 in for x, 0 in for y, and see if it works out, if you're ever unsure. Okay, going on to the next problem. So identify a variable that has no coefficient in front of it. You won't be seeing problems where there will be a problem without one. It gets to be a little advanced. I might throw in a couple in there for a challenge problem or something. But you notice how this one, there's that y. There's no number in front of it, no coefficient. Let's solve for y. So negative 2x plus y equals negative 17. We need to get rid of the negative 2x, so let's just add 2x on both sides. So y is going to equal 2x minus 17. So we'll just kind of scribble this guy out for now. And we're going to use this equation with this equation. So take the 2x minus 17, plug it in for y in the other one. So we have negative 7x minus 6 times the 2x minus 17, and that equals 7. And once again, we got to solve for x, so let's distribute that negative 6 through. So negative 7x minus 12x, 17 times 6, quick little 42, give me a 102. So plus 102, that equals 7. So we got negative 7x minus 12x, that's going to be a negative 19x plus 102, and that equals 7. Let's subtract 102 from both sides. So I'm going to get a negative 19x equals a negative 95. And then divide by negative 19 on both sides. So I get x equals and negative 95 divided by negative 19. I'm just going to use the calculator quick here. Oh. Give me a straight up 5. So x equals 5. All right, and then finding the y value. So plugging in x equals 5 into one of the original equations. So you could use this one, which is not the original, or the one I scribbled out, or this one here. Looks like this one right here might be the easiest one to use. So we'll have y equals 2 times 5 minus 17. So y equals 10 minus 17. So y will equal negative 7. So the point 5, negative 7, will be my answer for that one. So one more that I'm going to look at. and this will be the last one of the video. Again, identify a single variable without a coefficient. So once again, we have a y here. And maybe, this one will be all right to finish out the video. We have that y there. Let's solve for y. So we need to add 4x on both sides. So y will equal 4x plus 23. So I'll scribble that guy out. Plug this right here in for y in the other equation. So we have negative 6x plus 6, and then those parentheses, and then that 4x plus 23 goes there. So we have negative 6x plus 24x plus, let's see, we have 120 plus 18, so that'll be a 138. That equals 12. So we have 18x plus 138 equals 12. And then let's subtract 138 on both sides. So 18x will equal negative 126, and then divide by 18 on both sides. So let's see what a negative 126 divided by 18 is. That'll give me a negative 7. So these should all be whole numbers. On your worksheets, you shouldn't get a fraction. There are problems where you can have fractions, but these on the homework won't be fractions. So x equals negative 7. Got to find the y value. So let's plug that in for, let's choose this equation right here. Looks like the easiest one to work with. So we have y equals 4 times negative 7 plus 23. So 4 times negative 7 gives me a negative 28 plus 23. And negative 28 plus 23 will give me a y value of negative 5. So the point negative 7, negative 5 will be my answer.